Hi everyone, we're going to talk about the physical properties of carboxylic acids in this video. In general, because a carboxylic acid has both the carbonyl, C-double-bond-O, and an OH, they tend to have quite high boiling points and melting points, and also pretty good solubility in water. So if you look at the structure of a carboxylic acid, okay, if I go ahead and put in the lone pairs on the two oxygens and the OH, you'll see that there's actually quite a few spots where you could have potential hydrogen bonding. So I have a potential hydrogen bond here. These would be hydrogen bond acceptors off the carbonyl. I also have hydrogen bond acceptors off the oxygen of the OH of the carboxylic acid. And then I have that there. So there's actually potentially 5 different places where you could have hydrogen bonding. If you compare that to, say, an alcohol, okay, an alcohol only has really 3 locations where you could have a hydrogen bond. You have the 2 hydrogen bond acceptor, lone pair electrons, and this one here. So if you look at comparing carboxylic acids to alcohols in terms of their, let's say, boiling point, let's look at butanoic acid versus butanol. And if I just list boiling point in degrees centigrade, okay. Butanoic acid actually has a boiling point of 164, whereas butanol is 117. So the presence of both the OH and the carbonyl significantly increase the polarity and also the hydrogen bonding ability of carboxylic acids. There's also another interesting thing that carboxylic acids can do that helps explain why their boiling points and melting points are so high, and that's what's called a hydrogen bonding dimer. So if I were to draw out one carboxylic acid like this, and then draw another one over here like this, okay, so what I've done is I've basically just flipped over this carboxylic acid so that I position one of the OHs on one of the carboxylic acid next to the carbonyl, and likewise this one is now positioned perfectly to form what's called a hydrogen bond dimer. And this is a structure that carboxylic acids would adopt, say, in the solid state, and would help explain why their melting points are so much higher than like a corresponding alcohol. In general, carboxylic acids tend to be also very soluble in water because of the ability to make lots of hydrogen bonds. In general, once you get up to about maybe 7 or 8 carbons on a carboxylic acid, then the solubility would start to drop off. But lower molecular weight carboxylic acids, they tend to be fairly soluble. So that's a little discussion of that. In the next section, we're going to just talk about what happens when you treat a carboxylic acid with a base. So when you treat a carboxylic acid with a base, a very important reaction occurs. So if I were to take something like acetic acid, okay, this is one you definitely should know the common name of. It's called acetic acid. It also could be called ethanoic acid. We'll just list that out here. That would be the IUPAC name of this one. If I treat this with a base, we've talked about prior to this video that the OH of a carboxylic acid is in fact acidic. So let's say I treat this with sodium hydroxide. Now sodium hydroxide is a salt. So when I put it into water, it'll dissociate into the hydroxide ion. And now this hydroxide will come over and act as a base to pull off the proton. And in doing so, it's going to actually break the OH bond, and the 2 electrons of that hydrogen are now going to go over and reside on the carboxylic acid oxygen. And what that'll do, it'll convert the carboxylic acid into this compound, okay, plus water. Now notice that the oxygen of the carboxylic acid is now negatively charged. This is called a carboxylate anion. Okay, so it's a negatively charged species. And it's going to pair up with the counter ion, in this case, the positively charged sodium. So when you convert an acid into a carboxylate, it makes a salt. So we would name this in the following way. This would be called sodium acetate. Okay, so we basically just take the carboxylic acid name, we drop off the IC acid, and tack on 8. And then we list the metal in front of that name, so we get sodium acetate. Now, if I were to name this using the IUPAC nomenclature, the original acid is ethanoic acid. I would drop off the IC acid, and this would be listed as sodium ethanoate. Okay. More than likely, though, this compound would typically be called sodium acetate. In fact, I don't know if I've ever really seen it listed as sodium ethanoate. This is such a common acid, acetic acid, you really should know from memory that name is acetic acid. One final point I want to make about the carboxylates. This is now a salt. If you try and dissolve larger molecular compounds that have carboxylic acids, if they're in the carboxylic acid form, they're not soluble. So for example, if I take benzoic acid, okay, this is not soluble in water. Okay. However, if I convert it to the sodium carboxylate salt and get the compound sodium benzoate, this is soluble. So in general, when you make a carboxylate salt of an acid, the solubility goes way up. And this becomes really important when you start talking about drug molecules and their solubility and bioavailability in our bodies. All right, so I hope that helps clarify some physical properties of carboxylic acids. And you definitely want to get a few practice problems at ranking melting points, boiling points, and things like that. All right, good luck, guys.